At this question, and a couple of key points here. Well, we know that the tangent keyword, let me highlight the keyword, tangent to the curve, and another tricky bit is parallel to the x-axis. I'm going to go through that. Now, first of all, in order to work out the tangent, we find dy by dx, and in this case, y is not a function of x, like it is in C2. You have to differentiate implicit. Okay, so we find d by dx of both sides. The right hand side is just 0. So d by dx of 2x squared plus xy minus y squared plus 18 is equal to d by dx of 0, which is just 0. Okay. So first I'll do it term by term. I differentiate that with respect to x. I get 4x. Next, I differentiate that. Now, we have to be careful here. We have a product. The word product meaning two things multiplied together. So we've got u times v. Okay. We are now going to apply the usual rule, product rule, and implicit differentiation. So plus now. When I have a product, it's u, which is x, dv by dx, but v is y, so it's dy by dx, plus v, which is y, times du by dx, which is 1. So it's just y, minus the derivative of y squared. So the derivative, okay, so the derivative of y squared with respect to x, again, the rules of implicit, we differentiate it with respect to y, so it's just 2y, and then dy dx. The derivative of any constant with respect to x is just 0. Okay, so the 18 becomes 0, and the right hand side is still 0. Now, we now need to find dy by dx. So again, if you like, we factorize out dy dx, rearranging it and making dy by dx a subject to the equation. The algebra is very simple. This is year 9, year 8 algebra. Okay, but now you've got dy by dx to be made the subject to the equation. So it's dy by dx is equal to minus 4x plus y all over x minus 2y. And now here's the key. That is the correct answer. Now here's the key thing. What we need to do is find the coordinates of the points where the tangent to the curve is parallel to the x-axis. So dy by dx has to equal to 0 because the gradient is parallel, the gradient of the tangent is parallel to the x-axis. So we know that if you've got a fraction equals to 0, then the top part of the fraction has to equal to 0. Therefore, we know that our points must satisfy the equation 4x plus y equals 0. Y is equal to minus 4x. Okay? Simply saying that the top part of the fraction has to equal to 0. Now, I have here, I'm going to call this equation 1 because my point must satisfy that equation. And I'm going to call this equation 2 because it must lie on this curve. So I'll have a simultaneous equation to solve. So I can substitute okay, so we have y is equal to minus 4x and we have all this. So I call this 1, I'll call this 2, doesn't matter. Now I sub in Where I see y, I put minus 4x, so let's do that. So I have 2x squared minus 4x squared minus 16x squared plus 18 equals 0. So 18x squared minus 18 is equal to 0. If I divide both sides by 18, I'll get x plus, and then factorize x plus 1, x minus 1 equals 0. So x is equal to minus 1, or x is equal to 1. And when that's the case, y is equal to minus 4 lots of x. Going back to this equation, so when x is minus 1, y is equal to 4. Okay. And when x is 1, y is equal to minus 4. From here, we should see, just in case anyone's stuck, I've just divided through by 18. I've got x squared minus 1. That's how you factorize x squared minus 1. Again, that's C1. So just to be, because they want coordinates, the coordinate therefore is minus 1, 4, and 1 minus 4, just to complete the answer.